Recording in progress.
Okay, so today we are going to have session 2 on the artificial intelligence introduction, or whatever we talked about last time. We are going to build up the knowledge from that, and we are basically going to look at that how the concepts of mathematics relate to some of the machine learning concepts. So we are going to start with very basics, right? So one thing that we're going to look at is that some few mathematical foundations. Okay, so interrupt me when you feel like that you are not understanding anything, but otherwise let me just go on. So this is a right angular triangle. We know this is called a base, this is called a hypotenuse, and this is called what? This is sometimes called altitude. This is sometimes called perpendicular. So you can just say perpendicular. So according to the uh, theorem of Pythagoras, what do you know? If there is a right angle triangle like this, uh, which is having a side of say A, B, and C, where A and B is denoted by A, this is B, this is C. What does Pythagoras theorem tells us? Do you remember? Pythagoras theorem tells us C square equals to A square plus B square, right? Oh, goodness. This is too intelligent. Give me a minute. Why did this happen? So, okay. So what does Pythagoras theorem tells us? This tells us equals to C square equals to A square plus B square. Correct? You understand this, correct? Okay. Any confusion? We remember the Pythagoras theorem, correct? That the hypotenuse square equals to the perpendicular square plus base square, right? That is the Pythagoras theorem. So built on that, there is a we understand that there is a theorem on or a branch of mathematics called trigonometry, correct? What does trigonometry tells us? Trigonometry says us that if there is a right angle triangle, which is say having an angle of theta, which is this, and this is a right angle triangle. And similarly, we know that this is the hypotenuse, this is the base, and this is the perpendicular. So there are three representations of ratios of sides that we know of. So if there is a ratio of say so one second, this is why this is not coming up. Okay, so say this is called again the perpendicular. This is called the hypotenuse. This is called the base, right? Then how do we come up with sine theta? Sine theta was the definition for what? It is perpendicular by base. Okay. And then cos theta similarly. What was the definition of cos theta? The definition for cos theta was base by hypotenuse. Okay. Now tan theta, when we go, right, tan theta comes in a ratio of sine theta by cos theta. Correct? So in this two equation, we know that perpendicular by base is your sine theta, that into 1 by cos theta, which is like hypotenuse by theta. Okay, I think, give me a minute. I think I made a mistake in here. Give me a minute.
Sure.
Okay, so sorry, I'll have to rewrite it, and let's rewrite it in a different way that we can understand. So if we have a right angle triangle, write this, and if the angle of this is theta, I think that was the first mistake that I have done. This is the theta angle, and this is this is hypotenuse. The opposite to hypotenuse is called opposite, and this is called adjacent, right? So in this case, sine theta is defined as opposite O by hypotenuse. So the ratio of this and this is sine theta, O by H. Are you clear?
O for what? Base.
O is the length from here to here. H is the length of here to here.
A. A means perpendicular.
Perpendicular, right? Here till here.
Okay.
Okay, elongated the line. So A is still this position, right? So the ratio of these two sides are represented like this. So sine theta is the ratio of base by hypotenuse, which is like opposite. In other words, it is called opposite by base. So the theta expression, which is the angle between the two sides, which is like adjacent and hypotenuse, it is expressed in that. Then if you similarly go to cos theta, what is cos theta is? Cos theta is nothing but you get adjacent by hypotenuse, which is in this case, it will be perpendicular by hypotenuse. Now, if you go to tan theta, right? What is tan theta? Tan theta is nothing but sine theta by cos theta, right?
Hmm.
Sine theta by cos theta, correct? So when we simplify this equation, what was sine theta? It was O by H. Then this is H by A. This will reverse because it is 1 by cos theta. So this
Hmm.
and this cancels out. So you are remaining with what? You are remaining with O by A. All right.
Hmm.
So it is tan theta is nothing but uh, tan theta, tan theta. It is nothing but it is the expression of your opposite to your adjacent, right? So
Hmm.
that is how it is, right? So this is the basic of how we interpret sine theta, cos theta, and tan theta. This much we are clear, right? On trigonometry. Any questions about this?
So on what basis we are taking the theta angle?
It is the angle actually it is the angle between the two sides. You can consider this as the theta angle where it is adjacent to and hypotenuse is also there. Also, you can consider because if you rotate, if I mean this triangle can also be rotated like this, correct? So the theta angle becomes this one, right? So if you look at the right angular triangle, the theta angle is a angle between the base and the hypotenuse, or any one side or the hypotenuse, which is making the angle. So we are not considering the theta angle, which is between the perpendicular and the base, because that is right angular. Except that we can consider any either one of the angle as theta angle.
Oh, I mean, any angle can be considered.
Either you consider the top one or you can consider the bottom one also, which is fine.
Oh, okay.
Because if you are looking at the triangle like this, I can also try to rotate this triangle. If you see this line out here, this line becomes this line, correct? And this line then becomes the base, correct? Your
Mm.
hypotenuse is this. Then your theta angle changes. So what you are calling the base now, it becomes the altitude. So base and altitude can be converted to each other depending on the position of the triangle. Correct?
Base and altitude.
Yes.
And
And
for
but
all,
the hypotenuse remains the same. So any angle that you are making with the hypotenuse is the angle theta.
okay. And O stands for what?
O is opposite. They say hypotenuse is opposite. It is actually called base. So you can call it O, you can call it B, whatever.
Okay.
Okay. This is fine, correct?
Go ahead.
Okay, let's just come to the second thing, which is very important to understand, which is so this is a x and y coordinate, correct? So this is this is x-axis, this is y-axis. So in this point is called origin. This is 0, 0, right? And
Mm.
then here on this side of things, all the values of x and y, it will be positive and positive only. Correct?
Mm.
Here it is called y dash, it is called x dash. So this is the coordinate 1. In coordinate 2, in second coordinate, the value of x will be positive because you are still increasing from left to right. So, but the value of y will be negative, right?
Mm.
Similarly, in coordinate 3, I think I might be wrong in this order 2, 3, 4. Yeah, I think this is the right order. Anyways, this is negative and negative, right? And then
Mm.
in coordinate 4, the value of this would be negative and positive. Okay, this is the coordinate system that we know of. So any questions on this basic
No, that's
understanding of the coordinate? Okay.
that's okay.
Okay. So now any Cartesian, this is called Cartesian coordinate. Okay. In any point in this Cartesian coordinate is represented in this plane by two values, which is a value of x and a value of y. Correct? If I give any point here, it will have two values, x and y. Correct?
Mm.
Similarly, if I have a point here, it will have what? X and negative y.
Mm.
Correct? Similarly, minus x minus y, minus x plus y, minus y, minus x plus y. Correct? Okay. Now, any line that is kind of going from, one second, give me 1 minute. Sorry, I'm having a response that I need to give to my
Sure, sure.
chat.
Mm.
Give me 1 minute.
No worries.
sorry. So any line that goes from here, and if it makes an angle of theta, right? This line can be represented in an equation called y equals to mx plus c. This is the base equation of a straight line. It is linear in fashion because it is of equation of degree 1. What is the equation of degree 1? Which does not have any square, cube, or etc. Correct? So in here, one thing is represented as, say this is the line. So here we are saying that the line, that what is x, what is c, we will come to that. But in order for better understanding of this, say suppose the line would have started from a little higher up into the x-axis. So this is where the line started, correct? So the fundamental understanding is that basically the intercept or this area, it is called C, right? And when we get the change in the dimension, so the angle that it is going to make with the parallel to x-axis, it is called theta, and tan of theta is nothing but the slope. Okay. My God. This is called m. Okay, this is called m. So here y equals to mx plus c is nothing but m is called the gradient, and you can say that m is also called m is also called slope of the equation. Okay, so in other different formulae, or in the other different ways of representation of a particular straight line, this is called point in this is called the basically this is the general form, y equals to mx plus c. Then there is also something called this is called slope intercept form, y equals to mx plus c. There is something called point intercept form. So point intercept form is nothing but it is of the equation y equals to sorry, not y equals to, y minus y1 equals to m into x minus x1. So if x1 and x1 and y1 is a given point on the line, then the equation of that line can be formed by this equation, right? Now where m and x are, sorry, x and y are two generic variable, and x1 and y1 are the values which you are given. Okay, so hence there is a different way. Or before this, I should also mention that I mean there is a general way of calculation of slope. So slope is m. M is generally calculated by the tan of theta. It is also calculated by another perspective, which is called uh, given 2 points x1 and x1 y1 and given 2 points x1 y1 and x2 y2, your slope of a equation, and if these 2 points lies on a straight line, a slope of a equation can also be written like this. If m equals to tan theta, then your slope of a equation becomes y2 minus y1 divided by x2 minus x1. Okay, so x2 minus x1, x2 minus x1. Yes. So the way that we are getting this slope, this can be an angular way, or if the points are supplied, it can be, you basically subtract the y-intercept and the x-intercept, you would be getting the slope value. That is what is our basic coordinate geometry knowledge that is required. So in this case, why we are introducing this concept, right? Or why we are going back here? Because when we will be learning machine learning, this concept of slope, or this concept of tan theta, this concept of reading the points in a coordinate is extremely important, right? So we might cover this multiple time, and we will have to see that in many places, they given a particular point or 1 or 2 points, or we have to kind of like calculate the distance between that, calculate the Manhattan distance. We'll go to that, what is called a Manhattan distance and how it is calculated. And we can actually calculate the slope between 2 points, given the values of the 2 points, we can calculate the slope. So this is very basic fundamental for like, beginning of your trigonometry or coordinate geometry. With this, we can typically go into some of the machine learning concepts that it will be helpful to understand later. Is there any question on this till now?
So basically, y equal to mx plus c, basically it's the linear equation.
It is a linear equation because you do not have a square or you do not have a cube, right? If you have a square or a cube, the form of the light changes. Linear because the line is linear, right?
Line is linear, okay.
Mhm.
And c is the constant, m is the slope,
It's slope,
and
right?
x and y is the uh,
Variable on the coordinates.
variable in the coordinates. So,
Correct.
and I understood tan theta equal to sin theta by cos theta. But
Mm.
if I try to understand in the picture, which one is tan theta? And tan theta is slope, right? Slope means exactly what?
Slope is basically the measure of how much it is a definition or it's a measure of how much what would be the value of the slope, or that gives it that how much angular distance it is making uh, with uh, with the y-intercept. So to tell you in a better way, slope can be positive, slope can be negative. For example, let me clarify then. Let me see if I can find a good example in internet to show you that. If not, then I'm have to make one. So let's say you have a line which is making an intercept at the bottom. So wait, let me see if I can. Okay, say you have a line which goes from here till here, right? Now, in this case, the gradient m is basically what? Gradient m is basically what? It is or y equals to mx plus c. It gives you what? It gives you the angular distance of the theta angle that it is making in here, right? But if you see, this is a negative coordinate, right? So tan theta is going to be negative in this case, right? So basically, slope defines that how much angular or how much inclined that particular line is in reference to your origin or in reference to your both the coordinates. That is the measure. That is the measure. So by tan theta, you are just applying to get the measure, right? So if you say it is 45 degree, right? Which is like we know that um, I mean there are different tan values, right? So what is the tan theta of 45 degree? Tan theta of 45 degree is 1. So slope one means what? Slope 1 means it is parallel to x-axis because it is uh, sorry, I think sorry, tan 0 is 1 slope. Sorry. I think I am making a mistake. So this okay. So if you have a line which is like parallel to x-axis, what is the angle that it is making with the slope? It is making 0 degree angle, right? So then tan theta of 0 degree is equal to what? It will be 0. So you can say that this is 0, correct? Now if you rotate this angle slightly, this line slightly, right? It is making say 1 degree angle. So tan of 1 degree is what? It is tan of 1 degree is, say, suppose some value, 0 point whatever is the value. So that is the inclination it is having with the x-axis. That is the measure. Yeah, okay. So when you go to, say, from tan theta to say tan 30, or might be say you go to say tan 90, you would basically get the slope as undefined, because what it will happen is that tan 90 is what, when you have a angular distance which is like nothing but the y-axis. So the slope of this is never going to meet x-axis anywhere. Sorry, it is never, it is perpendicular to x-axis, right? This is 90 degree, correct? So the way that we are understanding this is exactly cutting the x-axis, and it is just going like like anything. So it is this tan of 90 degree is nothing but it is infinity, correct? So in the same way, if you say, if I have a line which is say it is cutting like this, correct? And I have a theta of this, the measure of tan or tan theta is equal to, is nothing but, what did we understood from the definition of tan theta here? It is O by A. What was O? Base by altitude, right? So if you see in this case, O is this, it is A. So this is O, this is A, correct? What this point is, this is X, this is X1, this is Y, right? This is Y1, right? What we are saying the definition of slope as, if you remember, Y2 minus Y1, Y2 minus Y1 divided by X2 minus X1, which is nothing but my distance between this and this. The ratio of this is going to give me the definition of slope, right? So it is a measure to calculate how much angle it is making with the Cartesian coordinate, or how much inclined it is to the Cartesian coordinate. Not Do not confuse it with the angle. It is a measure to calculate, or it is a measure to calculate the inclination of a particular line with the axis. It is a measure to calculate the inclination of a particular line with the axis, right? That is exactly is called slope.
Let me write it down.
Hmm.
Just repeat once again.
Okay, it is a measure
It's a
which
measure.
which defines the inclination of a particular line with the Cartesian axis.
Inclination. The measure which defines the inclination.
Of a line with the Cartesian axis.
Okay. It's called slope.
Yeah.
Hmm.
I mean, it is also, you can say, it is a measure of steepness, how steep the line is. Measure of inclination or measure of steepness.
Steepness. Okay.
Steepness, if you can
Mhm.
say, it is a measure of steepness.
Mhm.
How steep the line is. We know what is steep, correct? It
Mhm.
is, very, very steep. We say when we go up the hill, it is not very steep when we go in a plain area. It is the measure of steepness.
Okay.
Okay. So that is the definition of that. And how we get that value is taking the tan of that particular angle with the origin. Okay. With the origin, or with some parallel lines of the x coordinate. Correct. We get that particular angle. And when we get that particular angle, the measure that we are getting, we are just saying that how steep it is, right? Any questions in here?
No, got it. Got it. Go ahead.
Okay. So yesterday when we were discussing, I think we introduced a good concept. Let me just touch over it. So let's just flip for a minute from basic maths concept to, I think, the data concept that we were having. So typically there is a mm, there are three kinds of data that we talked about yesterday, if you remember, right? There were there were training data set, there were testing data set, and there were prediction data set. So if I say that this is input, this is output, and this is training training data. So this is testing data, and this is predicted data. Do you remember what did we talk about yesterday? In training data, both input and output is known to me plus machine, right?
Hmm.
Output is also known to me plus machine, right? If we have a testing data, the input is known to me, the input is also known to machine, right? But the output is only known to me. The output is not known to machine. In this case, the predicted input is known to machine and it is also known to me. Output is not known to machine, not known to me. You remember this discussion yesterday?
Yes.
Yes. So from here, there is one important concept that we should understand. It is called confusion matrix. Let's go there. So there are basically, what is confusion matrix? So if I say that I have a model to predict if somebody is sick or somebody is healthy. So what I'm saying, here is a model. This is a model. Okay. It predicts sick or healthy. Okay.
Hmm.
So now there can be four cases. Somebody can be predicted healthy. Sorry, if I have to rewrite this. Okay, let me write it in a different way to make you understand. Okay, so the model, somebody can say that the model can say that it is telling somebody is predicting, predict, predicted is healthy. And actually, the person is healthy. This is a good case.
Mm.
This type of prediction is called true positive. Write it down, because this is very important.
Okay.
Okay. Now, say the model is saying that somebody is predicted healthy. Predicted is healthy. But the actual result in reality, he is sick. This is called false positive. This is also called type 1 error. Okay. Now there can be another two case, right? Now the model says that the predicted is sick, right? And actually the person is sick.
True negative.
This is called true negative. Okay. TN. The only other case that is remaining, it is predicted is sick, and actually the person is healthy. This is called false negative. FN, or this is called type 2 error. Be very clear about this terminology, because this is the fundamental of machine learning.
Last one is prediction is sick, actually is healthy.
The first one is not that. The last one you are saying. The last one is that, yes, the model says that the person is sick, but actually the person is healthy.
So the terminology will come with model prediction.
Yes.
So
So let me make this a little easy for you. So if you think outcome of a result is positive, first of all, try to understand being healthy is positive. Understand my line. Being healthy is positive. Understand this. Okay. Then it is very easy to understand the whole scenario. If being healthy is positive, then the first one is what? True positive. True positive means actually I am positive. Actually I am healthy, which is true, which means the actual is true.
actually true.
Actual healthy is true. That means healthy equal to healthy, right?
Correct. True positive. I
True
understood.
positive, right? Now, if you think that again, that being healthy is positive, right? But actually, it is actually I am sick.
False positive.
So what is actually,
Means which
I
is
mean,
not.
which is not correct. I'm telling that. So actually I'm sick, right? So that is false is positive.
Yeah. The opposite is positive.
Opposite is positive. right? Similarly, actually I'm sick and true predicted I'm sick, which is true negative.
Mm.
Now you will understand.
True, because true negative, because being
Negative
healthy is
negative is positive.
positive.
Negative negative is positive. Truly
Okay.
negative.
Mm.
Okay.
And this is nothing but kind of evaluation when we are going to evaluate the machine output, is it?
Yes, yes. Now over here, there are three things that we need to understand. So there is something called precision. Precision is the measure of the accuracy of positive prediction. It is by definition, it says it is the measure of accuracy of positive predictions. So which means that the formula for precision is true positive divided by the total number of true positive and false positive. Which means that all the items which are labeled positive, how many are actually positive? Out of all the items which are labeled positive, see, when we are talking about precision, we do not need any negative observation. We are only considered with positive. So this was the positive observation, this was the positive. There were only two cases. Other one was false negative, true negative, correct? So out of then the whole set becomes FP plus TP, all the positive observations, whether it is false or true, right? That goes into the denominator because I need to find a percentage or whatever, right? Accuracy of the positive prediction is what? Number of observations which were actually labeled positive
It's kind of
out
50%.
of the whole positive. Out of the whole positive. No, it is not 50%. It can be anything. It can be 80%, it can be 20%, it can be 48%, whatever. It depends. What we need to
Oh,
understand is that this is a measure of accuracy of the positive prediction. So when we are saying the accuracy of the positive prediction, what we are telling is that of all the items that is labeled positive, these are all the items that were labeled positive, right? How many was actually positive? This was the only item that was actually positive. These were the number of items that were actually positive. So the ratio of this becomes my precision. Okay.
precision. Okay.
This is called precision. Another matrix is there called recall. Recall is nothing but, recall is, you can say, the ability to find all the positive instances. The ability to find of the positive instances is what? Of all the actual positive items, how many were identified correctly? Now, how many was identified correctly means what? How many was identified correctly? This is the correct identification because prediction and actual matches.
Means
This is
true
the correct
prediction and
identification.
false,
This is these two are the only correct prediction where the model
true
was
positive and
100%.
false positive. Yeah.
True positive, no, no. True negative and false positive. True
Sorry, true
negative,
negative. True negative
right?
and true positive.
Wait. So then in denominator, if we have to find every time how many times that this works fine, this is nothing but true positive plus false negative upon what? What was the actual number of true positive result? So this is a measure of what? How many was identified correctly by the machine? How many was identified correctly by the machine, right? Recall is nothing but that.
Oh, okay. Mhm.
You
But
understand?
in denominator, you wrote TP plus FN means two
Fn,
positive.
because in only in these two
Mhm.
cases, Partho,
Mm.
my model worked correctly. Prediction equal to actual. Prediction equal to actual. Prediction equal to actual.
True, or TP plus TN then, right? Plus TN.
Sorry, I think I misspoke. Yeah, it will be TP plus Fn. It will not be TP plus Tn. So the thing is that it will always be out of the actual positive items, how many was identified correctly? Now, out of the actual positive item, right? So this is where the model correct, this is where the model prediction was correct, right? But this was not the actual positive item. What was the actual positive item? This, correct? Actual positive was only two places, actual healthy and actual healthy, correct? We should
Actual
not
healthy
consider
and
actual healthy. It was only in two places. This is Fn, this is TP.
okay.
It is,
Ah,
yeah. So
mhm.
out of the actual positive, these were the two actual positive where the actually it was healthy and it was actually healthy. Hence Fn is coming. This is correct. This is correct, by the way.
Okay, okay, okay. Mhm. Means
I,
where, I mean, we need to consider only healthy part. Actually,
yes, 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 yes,
mm.
yes. So out of all the positive, how many was identified correctly, right? Okay. I think there is another thing that we need to start. It is called F1 score and area under the curve, but we do not have time to go there. I'll stop the recording here for today.